Hello guys, my name is Dr. Andy Fowey from the School of Biomedical Sciences. I'm here to give you an experience of lectures that you might encounter in your first year as an undergraduate at the University of Plymouth. Here I'm going to give you an experience of infection and immunity. I am lecturer in immunology, so it makes sense for me to talk about Immune Fight Club. Now at this point of a lecture, I would normally risk getting fired by the university because I invite a student up to the front and threaten the student with physical violence. Now, it's not that I'm looking to get fired, but what I want is to demonstrate a point that if you put some sort of aggressive challenge in front of a subject, how is that subject going to respond? Normally, when it comes to immunology, we just think about the immune system. But to really understand the immune system, we've got to see it as a dynamic battle between good and evil. So it is an immune fight club between the immune system, the good system of the host body, and fighting the baddie, which is the pathogen. And ultimately what I want to demonstrate is if I was to suddenly punch a student, how would they respond? Now I hope that the student wouldn't just stand there and take it as I'm sort of punching them in the face. How are they going to respond? Well, self-preservation might dictate that they would respond by either ducking, running away, or the more bolshy amongst the audience might turn around and say, I'm not taking this, and decide to throw a punch back at the lecturer. So ultimately, the Immune Fight Club is a dynamic battle between two sides, and that I want to equate to the famous fight between George Foreman and Muhammad Ali, the Rumble in the Jungle. No boxer is going to just stand there and take punches from the other. They're going to try and defend themselves or punch back, or they might have a strategy, as with Muhammad Ali, have a strategy to be able to overcome the fighter, in this case a pathogen. When we start off with immunology, immunology is a really hard, difficult subject which is full of nomenclature. Now, if I was to read this out to you, I want you to think, what do you think about this statement? Inflammation is driven by a cellular collaboration between CD14 positive, CD16 positive monocyte-derived macrophages which cognately interact with both CD4 positive and CD8 T helpers and cytotoxic T cells to initiate both cell-mediated immunity and cytotoxic events, regulated by CTLA4 positive, CD4 positive, CD25 positive Tregs, deficiency of which leads to autoimmunity. Right, that was a big mouthful. I would imagine that half of you are thinking, what the heck is this guy going on about? And the other half are thinking about just getting up and walking out of the lecture theatre. Well, this is one of the problems with immunology. It's got a lot of terminology, and this terminology makes it almost impenetrable. So my job is to really break it down and start to get you understanding the principles before we can add the vocabulary to it. If we're able to understand the principles, then the vocabulary that you see here in this statement will suddenly make sense, and what seems like a very complicated statement will be second nature to you by the time that you've progressed to final year immunology modules. So let's take this further. When we think about this dynamic battle between good and evil, between the host immune protection service and a destructive pathogen, what we've got to consider is how do we respond to the pathogen? Well, it first starts by surveillance. You've got to be able to recognize a pathogen as potentially harmful. It's then followed by the intel about the pathogen that's passed to the immune system. The immune system ultimately is racist, and ultimately it's about xenophobia. So the immune system is all about responding to foreign stuff. All right, so anything that is foreign is seen as something that's potentially harmful, and we want to mount an immune battle. And the immune battle results in conflict. Ultimately, we want to kill the pathogen and we want to clear it. And once it's cleared, the immune system is switched off and peace breaks out. So that is the immune battle in one simple slide. Surveillance, intel, xenophobia, conflict, and peace. It starts originally by recognizing and being challenged by a pathogen, the enemy. We can all relate to the pathogens that we might come across. Some of us might have been infected by some of these pathogens already as part of our progression in life. The pathogens include virus, and at this time everybody's talking about COVID-19. They might be bacteria, they might be protozoa, which are unicellular parasites, or they might be helminth worms, so big multicellular worms. All these pathogens can damage the host. The host wants to recognize them and respond appropriately to them. So upon recognition, it's about mounting the right response by the immune system. But the immune response only is elicited once the pathogen gets into the body. So as part of the infectious process, the pathogens have got to bypass natural barriers of the host. And these include the skin and the mucosal or sticky surfaces, such as the gastrointestinal tract, the respiratory tract, or the urogenitary tract. So the baddie, the pathogen, has to get past these physical barriers before it's infectious, it can create harm, and we want to recognize and mount an immune response to defend ourselves against this infectious agent that breaks through our barriers. How do we do this? Well, the immune system has got a very much a broad spectrum, blunt edge response, which is not very clever, and we've got a more specific or cleverer response, which is more targeted towards the pathogen. What I want you to think about now is I'm going to relate to a battle group in the middle of a battle. You might think that it might involve infantry soldiers. It might involve soldiers such as the SAS. It might involve the Royal Navy or the Royal Air Force with their particular armaments. So what I want is to relate how a battle goes on a battlefield and then be able to compare it to the immune system. So once a pathogen breaks through a barrier, it's all about a very quick, immediate response. This quick, immediate response is the innate immune defense response. Now, as I suggested, this is a rather blunt-edged tool. This utilizes cells of the immune system which can target, but non-specifically, the pathogen. So it's rather like an infantry soldier lobbing a grenade at the enemy. The grenade might kill the enemy, but it might kill an awful lot of civilians around that enemy. So there is an element of collateral damage to the host tissue because this innate defense isn't very clever, it isn't very targeted. The sort of responses that are elicited as part of the innate immune response are inflammation. We all relate to inflammation and realize that inflammation can be quite damaging. Well, that is because we've got cells of the innate immune system, such as macrophages and neutrophils. They have weapons of mass destruction, which, as I hinted to with the grenades, they can kill pathogens, but they can also be very destructive to host tissue. So it's not very clever, but it'll do for the early response. But what we want to do is elicit a clever response. So here, this is where the SAS are introduced into the battle group. The SAS are more clever, have a different range of armaments, and one of their main functions is to act as snatch squads to be able to gain information. So on the battlefield, they might interrogate an enemy to gather intel of what the enemy is doing and what the enemy is planning to fight against us. The SAS does that, but in the context of the immune system, the intel that's gathered is all about the pathogen, the antigens from the pathogen, the site of involvement, and how much it's damaged. So the SAS can be replaced in the immune system by cells known as antigen-presenting cells. And antigen-presenting cells communicate to cleverer cells to mount a more targeted, less damaging response. This less damaging response, a clever response that's more targeted, is about adaptive immune defense. Now, adaptive immunity is about developing antigen-specific or targeted immune defenses that are a little bit more targeted than innate immunity. So what we've got here is a nice cartoon where you can see the officers, and here we've got the officers in the officers' mess. And the officers, they're the ones that process the information that's been passed by the antigen-presenting cells, or the SAS, and they formulate a plan of action. Once they've formulated a plan of action against the enemy, or the particular type of pathogen, they then have to instruct other parts of the battle group. And here these officers in the HQ, the headquarters, also known as the lymph node in the body, these officers instruct the artillery or Royal Armoured Corps, or they can instruct the RAF or the Armoured Corps of the Army, and they use different armaments. If we use the Royal Artillery, then shells that are launched will be targeted, but they're quite destructive and can result in some collateral damage. Whereas smart bombs that are wire guided by the helicopters here, they are more targeted and will destroy the enemy without affecting the host cells. So very little collateral damage. Dependent on the pathogen, these cells in the HQ, these officers, are known as T cells and B cells, and they can instruct two different types of adaptive defense, either humoral defense or cell-mediated defense, and this is rather akin to using our smart bomb or our megaton bomb in responding to the pathogen. One is highly specific and only destroys the pathogen. The other is less specific, destroys the pathogen, but can result in collateral damage of host tissue. Ultimately, this would be the first slide that I would give a first-year undergraduate as their introduction to immunology. So what we've done is we've put it together piece by piece, and it all starts in the top left-hand corner when reviewing the immune battlefield. We ultimately start our immune response by recognizing the enemy, the pathogen. How we recognize it elicits a first non-clever response, from the infantry soldiers wearing the green helmets there that can launch a destructive inflammatory response using those hand grenades. But ultimately what happens in the process is that we also get recruitment of dendritic cells, or the APCs, also known as the SAS. They gather information and they can take it back. So as APCs, these SAS soldiers pass the information to the HQ, or the T and B cells in the lymph node, and it is these cells that instruct the more clever responses to be elicited by adaptive immunity. So we've either got the armoured corps or we've got the helicopters. And these can either elicit, through their armaments or immune effector molecules, these T and B cells can either elicit a highly targeted response or a relatively non-specific response that can result in collateral damage. So we've got effectively an immune battlefield with many player cells and many player armaments, and all of this is dependent on which pathogen is present, how we recognize it, and how we recognize it determines how we respond to it and whether it's efficient or not at killing and clearing the pathogen. So to summarize, pathogens are numerous and varied. We have both simple and complex immune mechanisms to deal with these pathogens. And that very importantly, the immune system is not just one way, that as soon as the immune system is activated, we are going to win. No, far from it. The immune battle is a dynamic two-way process. It is our own personal immune fight club. And who wins, either the host or the pathogen, the winner is determined by ultimately who is strongest and who is the cleverest. That is the end of this introductory lecture. I hope you enjoyed it, but as I said, it's more about getting the concepts on board first. And once you start in as an undergraduate, first year in biomedical sciences or human biosciences, the immunology lectures will progress from this simple basic concept to add the vocabulary so that we can start to increase your understanding and ultimately be talking and presenting in the same way as that very complex statement in the first slide. Thank you very much, guys, for listening. I hope you enjoyed it, and I very much hope to see you in the University of Plymouth sometime soon. Cheers.